Who is familiar with the mic drop meme? Show of hands, please, if you will. Fab. KnowYourMeme.com describes it as the practice of intentionally letting a microphone fall to the ground as a display of bold confidence following a successful performance. Colloquially, the expressions have also been used to celebrate the delivery of an impressive performance. The practice of letting a microphone drop on stage was popularized by rappers and comedians in the 1980s. Unfortunately, I saw the mic drop meme used once in the context of LinkedIn in a semi-professional context and wildly misinterpreted it. I went through like a short but slightly cringy phase of thinking it was appropriate in a work context. Whilst I wish I had the confidence of a 1980s rapper comedian, I'd also misinterpreted it, unironically, to kind of mean, here's a write-up or some kind of written artifact that I've worked really hard on. I'm handing the mic over to you, which is where I think the misinterpretation came in, and I would really love your feedback. So that resulted in some wonderful one-liners appearing in Slack, such as, here's the spec I wrote on this feature, mic drop. Please review this longish pull request I've been working on when you have time. Mic drop. Here's a copy of the peer review I wrote for you. Mic drop. English is my first and only language, in case you were wondering. This cute little anecdote was trying to be a segue into the fact that so you can imagine my horror when a colleague, actually it was in the peer review case, my colleague questioned me very gently and kindly, questioned me on my continuous use of mic drop in a completely inappropriate context in Slack, and we figured out the misunderstanding. So to my horror, I had to go back through Slack, find the edit button, and remove any and all history of me misusing that phrase. Let's just say on that day, I was incredibly grateful for mutability in the Slack product. So I wanted to use that as an anecdote to illustrate that there are some cases in which mutability is desirable in a product, but the public APIs are not one of them. With that elegant segue, I'm here to introduce the notion of resilient REST APIs, and in particular, the parallel change approach to evolving REST APIs using largely immutability and other functional programming practices. I'll start off by motivating API evolution, why we might want to evolve APIs and kind of what that term means. But in particular, this talk will be broken down into the why, the what, and the how. Why do we evolve APIs? What does API evolution look like? What approaches exist for API evolution? And how do we apply parallel change in practice? I work at Artificial API. We're an insurance technology solution. And so we've been applying parallel change in our customer-facing APIs, REST APIs. So I'll talk to you about the why, what, and how. First off, why evolve APIs and what does that mean? Let's take a look at an illustrative example. I'm going to show you an entity relationship diagram, so just hold your breath. So I've massively simplified like an obfuscated version of what we might produce artificial API. So we want to provide information about insurance products. So this diagram is illustrating that we have two operations at the top. We have an operation to get all policies and get a single policy by ID. The policy schema currently in our small example has an ID, which is of type integer, and a status, which is of type string. It's effectively an enum where the policy status values are shown below. The change we'd like to make, or the evolution that we'd like to make to this API, is to change the policy ID to use nano IDs rather than an integer ID. This might be for a few reasons. We might find that we're having problems with we just have loads of policies and we're getting to really large numbers, and it's not really sustainable, it's not really scalable for multiple clients, multiple deployments, or very large numbers of very large results. So we want to use something like a string ID which uniquely identifies policies in a better way. We've decided we want to use nano IDs because we've heard they have a lower chance of collision and they're slightly nicer in URLs in the URL structure versus other unique identifiers like UUIDs. I will very briefly show you a version of this API in the Swagger editor. If it loads, it's just because it's got a... Oh, no, I won't. because I think I'll figure that out later. Screen mirroring. So later on, I'll show you a version of this API in the Swagger editor, but it's not super important right now, as long as you get the basis of what we're trying to change here. So why do we evolve APIs at all? This is the same change expressed in the sort of HTTP request and response. So we, from the user's perspective, they'll send a request to this cute API artificial.io/policies endpoint, and they'll receive back on the left-hand side the original version of the response would return a list of policies with integer IDs. The change that we would like to be observable from the client's perspective is on the right-hand side. So we want the client to be able to send a request to the policies API endpoint and receive policies back with a string ID. So then this is kind of a small example of what the nano IDs look like, shortened version of what nano IDs look like if you're unfamiliar. So we've seen the change in the problem expressed as both a diagram and the request response cycle from the user perspective. So in the context of APIs, this seemingly minor change is considered a breaking change because depending on the way that the client has implemented their handling of this response, it might well be that they're unable to parse the new structure, the new string value of the policy ID. So we consider this a breaking change. We'd like to avoid those. But I want to briefly touch on the differences between backwards incompatible changes and breaking changes in order to motivate the following sections. So in the context of APIs, a change is backwards incompatible when the API requires more. So for example, adding a new validation rule to an existing resource, adding a new required parameter, or making a previously optional parameter required. A change can also be backwards incompatible when it provides less. So we remove an entire operation, remove a field in the response, or remove any kind of data, remove an element from a data structure where we have certain guarantees. So for example, enums. If we remove a value from an enum, that's considered a breaking change. Alternatively, a change is backwards incompatible when we change the semantics. So when the API changes in some user-visible way, i.e. we change the path of an endpoint, we change the type or parameter of a response field, or we change the authentication or authorization requirements around the API. So for breaking changes, any change that causes a previously valid request to become invalid is a breaking change. And backwards incompatible changes, i.e. the style that are on the left, become breaking changes when they're applied by default for the client and force the API consumer to change their behavior in some way. So in this example, to change their front end to manage to handle strings instead of integers. So why evolve APIs? And one thing I should mention is backwards incompatible changes are largely inevitable in a lot of real-world or trivial interfaces, but breaking changes on the right-hand side aren't. So in our opinion, it's our goal as designers of this API to provide a functional, easy-to-use, and unsurprising interface that doesn't change given the same request, where the response doesn't change in surprising ways given the same request. So changes or new functionality should be introduced with minimal impact to the consumers of the API. So this means two things. We must avoid making breaking changes, and we must also provide a smooth migration path from the old to the new capability. So we've spoken about API evolution, why it's a motivation, especially for public-facing interfaces, or published interfaces rather. What approaches exist to try and manage these changes in a graceful way that has minimal impact to the consumer? I've mentioned a few of these. This is by no means an exhaustive list. These are just the three that I've decided to put examples of, and some of the more common examples. Each approach is more refined, becomes more granular as we go down. So we'll start with versioning the API. So here's an example of how we might make the change and what it looks like from a user's perspective if we version the API by adding the version in the path. So prior to the change, the user would, the format here I've used is a diff, so I'm sure most of us are familiar here, but just to clarify, red lines, or those prefixed with a minus sign, represent the kind of change before, or removals of code, removals of changes in the response type, and green lines on the right-hand side effectively illustrate the after, additions to the response payload, and so on and so forth. So before the change, the user sends a request to, let's say, v1 policies, and receives the response back with the integer ID. On the right-hand side, the user sends a GET request to v2 policies and receives an ID, a string ID with a nano ID. While this approach is very straightforward and very common, it does have some drawbacks. It's very heavy-handed. It affects the whole API. So we either need separate Open API definitions. We haven't yet seen the Open API spec, but we will later on. It will necessarily require completely new versions of the API. It's quite costly in terms of development, documentation, and maintenance to manage two entirely separate versions. And it can lead to kind of API version sprawl if overused. So if, for example, you're creating a new API version for a very minor change, this wouldn't really be appropriate here, and we'd end up with too many versions to manage effectively. I'm not really going to talk about semantic versioning where we version by major, minor, and patch in this talk, because we don't see it in any of the examples. We're just using them. We're using the major version effectively in the URL when we use v1 or v2. That illustrates that something is a breaking change. So to summarize, this style of change can be appropriate, but it's more appropriate for significant API changes if you're making wide sweeping changes to multiple operations or schema at the same time. For our case and for this example, a more granular approach like schema and operation versioning might be more suitable. So here's a very, very similar looking change. The only difference here at the top is we've introduced header. The API producers have implemented header and handling code so that we can allow the client to send a request to the same endpoint. So we don't have v1, v2 in the endpoint path anymore, but we do require the client to include a header that specifies the operation version. The response types are exactly the same before and after, but it involves, from the API producer's perspective, some handling of the HTTP header and effectively code switching depending on the value of the operation header, operation version. Benefits here, as before, clients can choose which version to use. This level of granularity is more appropriate to small changes like the one that we're looking at, changing the ID type. It's possible for clients to default or revert to older versions, and it uses standard HTTP headers, which many people are familiar with. The challenges here, though, are that it requires the client to introduce HTTP headers with their requests, potentially all of them. If you don't set a default, then the client might have to specify HTTP headers on every single request. The likelihood is that you're going to provide a default, and it might default to the latest version. If you do that, then your requests effectively, they're still changing from the user's perspective. If the user sends a request to the same endpoint /policies, and we've changed the default version from 1 to 2, then that still breaks the client's expectation. So they're going to have to still make a change to handle, even if they want to revert back to version 1, they're going to have to make a change to handle that in the request. That's a purely hypothetical scenario, but it is one that we see quite often. So in all, this approach offers more flexibility than for API versioning, but we're still expecting the client to do something, especially if we set default values for the header. Which brings us to our final option. Spoiler alert, this is the one that I'm going to be encouraging us to think about whether we can whether we can use more often when we design public-facing interfaces or published interfaces, is the parallel change approach, which is the idea that we do not introduce a breaking change at all. We don't require the client to do anything new to handle this new type. And so I suppose the crux of this kind of change is to take something that we might ordinarily put behind a new version, even if that's a minor or a patch version, a minor version really, and consider whether we can make the change in a way that is purely additive to the contract, to the API contract from the client's perspective. So this is what that looks like effectively. Instead of changing the ID, the type of the ID, we add a new field which represents the ID that we would like, the new style of ID that we would like. And so there's no change here to the request, and a purely additive change to the response. So this is one example of how we might transform breaking changes into non-breaking ones and minimize the maintenance burden of multiple API versions. So the parallel change approach suggests that we add new capabilities alongside the old so that the user has access to both at the same time. They don't ever have to change their request if they don't want or need to, but they always have access to the new capability if they so desire. The parallel change approach has some I suppose opinions or suggestions about how we make this change as designers and API developers, or really developers of any software, is that we split what might ordinarily be a breaking change into 3 separate parts in order to convert it effectively from a breaking change to a non-breaking change. These phases are expand, migrate, and contract. During the expand phase, we introduce the new capability in parallel with the old, as we saw just here from the user's perspective. Critically, we mark the old capability as deprecated. I think I removed an example where we looked at how to do that, but if you were producing an API, generating an open API spec from here, for example, and this was in your user-facing documentation, the documentation for the API would have a really clear a comment and also a field that says deprecated true. Next would be the migrate phase, which is where we move API clients from the old capability to the new. And then the contract phase. Once all clients have migrated, we remove the old capability from existence and all other artifacts, code and documentation and so forth. So parallel change has a lot of the same benefits as versioning at the operation or schema level, in that it allows the client to switch from old to new capability at their own pace and at a level of granularity that is that can be more casual for them. This can be quite, that might sound like a small thing, but it can be incredibly important where you have a lot of, where you work with, I suppose, heavily regulated industries, for example, where version changes, especially minor and major version changes of software, involve several stages of, going through and understanding what the whole subset of changes associated with that API or that minor version change. So being able to, from the client's perspective, being able to access a new capability without technically switching to a new version may be the difference between something taking 30 seconds to access a new field and 3 or 30 days to access the same capability, through the levels of, I suppose, the challenges that are associated with changing versions potentially. So lower migration effort and risk. I think I've covered that one. Clients have immediate access to new capabilities, and they can flip back and forth as they like. A flexible migration timeline. If you wanted to, you can access capabilities of one endpoint or one set of operations and keep the capabilities of the old one. You don't necessarily have to switch wholesale to a new version. However, the disadvantages of parallel change might be that we still have to maintain multiple code paths. This is kind of the same with each of the approaches we've seen so far. If we want to offer two versions or two sets of capabilities, we're going to have to we've introduced them into the code base, so we need to maintain them. there is a risk of slow client adoption, especially where clients have access to both things at the same time. There might be less of an impetus with a parallel change approach for them to switch from one to the other. So we'll talk about ways of managing that later. And it also requires potentially some extra monitoring and communication effort, by which I mean, if we want to understand how and when to deprecate particular capabilities, we need to understand how and who is using those capabilities. So we need to introduce some monitoring to get a better view of that. And communication effort, because we'll always need to communicate with clients when we're about to remove or deprecate something to make sure that it doesn't become a breaking change. So you may have noticed I've phrased all of the advantages of parallel change as advantages from the context of the consumer's perspective and the disadvantages and from the API producer's perspective. This is kind of intentional. Like, parallel change is a way to improve the API consumer's experience, but it does come at the cost of additional maintenance and potentially additional work for the API, for us, for the API producers. But I revisit the slide at the end of the last section, which is, as API producers, or the producers of any published interface, it is our responsibility to evolve the interface in a way that's thoughtful and not disruptive or minimally disruptive to the API, to the consumers. We make as designers and developers of anything that's going to be consumed by someone else, we need to make a proactive decision to not break user space, to use that phrase, and to prioritize the consumer's experience over our own, where it makes sense to. So I mentioned some advantages, disadvantages. Most of the disadvantages fall on the producer's side. So are there some ways that we can mitigate some of the development and maintenance burdens in real life and make parallel change a compelling choice for both the API producer and the consumer in a way that's not a headache for us as the developers? So this is what I'd like to explore next, using our experience of parallel change at Artificial. So I mentioned there were 3 phases: expand, migrate, and contract. I'll use each of these phases to kind of highlight a couple of things that we've learned at each stage. And a bit of a disclaimer, even in the process of working on this talk and thinking about some of these ideas, which are by no means new, we're learning new things all the time as well. So there'll be things here which I will definitely ask, probably after the break and things like that, ask about other folks' experience if they've done something differently and it's worked really well for them. But this, at the moment, is our experience in using the parallel change approach. So, at the expand stage, we changed the interface to support both old and new capabilities. One of the things that we've learned that we want to try to do is to design with forward compatibility in mind, i.e. thinking about at the design point, at the point of which before we write the code, how this might affect the consumer if we have to deprecate or remove that capability in future. So to prepare schemas for resilience against breaking changes, one of the approaches is super simple. We just tried to actually use object types wherever possible. So object types really are our friend here. And I think I'm going to try and go back to the Swagger definition. Yeah, here we go. So is that visible to folks? Yeah? I'm going to assume yes, unless you shout. So here is the OpenAPI spec for this effectively this dummy API. This is the before phase. So we have our policies operation and another operation which gets a single policy. At the moment, we have a list of policies. This is an array of policies. And to illustrate one of the things that we discovered would help us with future changes and to make parallel change and elegant API evolution more easy in future was to identify where we can change array response types to object response types. So it really is super simple. We're just doing something like, this is in the generated OpenAPI spec, so we would do something like an object. Oh, actually, I think I've got where it's, instead of items, it's like policies. And that's not our object is not included allowed fields. Anyway, I've got a better illustration of that, I think, in the next part. So a smaller example of hopefully a clearer illustration of what this approach might look like is we have a Haskell data type for the policy API before the change on the left-hand side, and the same representation of a paginated version on the right-hand side. So here, the difference that we've made, the change that we've introduced, is introducing pagination, for example, to the API. So what does that look like? At the top, we have the definition of the data type for the policy API, where we have get policies. I've missed out the single policy endpoint. And the policy contains ID, nano ID, and status. One of the ways that we can make this more forward compatible or more flexible when we come to make changes to the API and evolve it is to take a look at the right-hand side, change the array of policies, which you see on the left-hand side, where we have get JSON policy. That's an array of policies, converting that to a paginated policy. So there we have effectively a wrapper or an envelope data type, which wraps the reasonably generic, which wraps the items. So keeps the items in an array, but then introduces some extra fields. So, for example, integer for the cursor URL and next cursor URL, which effectively allows us to traverse through a page of the responses. So here's an example of one way that we can make the expansion phase a lot easier for ourselves as API producers is by looking for opportunities to replace more fixed types like arrays with, at least as they're generated and produced in the Open API spec, replacing arrays with objects. Other things we've learned from doing the expansion stage. So we work with the APIs defined in Haskell, and so we really do leverage a lot of the language and tooling features. And we've kind of learned to do that according to the ecosystem, whatever language it is you're working with. So for us, building an API in Haskell, that's relying on Haskell's strong static type system, and then it means that changes are as easy as potentially just adding an extra field to the policy data type. And then if you wanted to be really lazy, just seeing where the compiler tells you to change things. I mean, we can get a bit of a view ahead of time what changes we would need to make. But if you wanted to do a step through, that's really nice and easy to do as well. Haskell has a bunch of other really useful libraries to help us here. So we use Quick Check to run a bunch of property-based tests, as well as unit tests. But we can do things like check orthogonal compatibility. So if we introduce two fields in two different data types, for example, that might be related to each other in some way, we want to be able to reasonably exhaustively check the combination, how those two things interact. And so we can use things like property-based testing to do that. Finally, if we want to reduce the amount of code duplication isn't necessarily a bad thing, but one approach to minimizing code duplication when we anticipate we might need to deprecate something is to implement the old version in terms of the new version. So what that might look like here is that we have a version of get policies handler, which I've not included here for the sake of space, but we might be able to implement the get policies handler so that we, instead of duplicating a bunch of code that returns either a policy with integer ID or string ID, we can just implement one in terms of the other to reduce a bit of code duplication. So all of these things, preparing schemas for resilience against breaking change, using object types, using language and tooling features, and trying to minimize, where possible, some duplication, helped us to introduce the change quickly and with a reasonably high level of confidence that nothing would be impacted. Next, the migrate phase. So at the migrate phase, we update clients from the old to the new versions. And this is likely to be the longest running phase for any published interface, regardless of what approach you use, any of the approaches that I've listed. A successful migration phase really hinges on having clear and good communication with clients. However, what we found is that we can also use things like tracing and observability tools to prompt the discussion. So artificial, we collect some telemetry data. Our tools of choice just happen to be Jaeger and Grafana to pull some information regarding the usage of the API, and to illustrate it in things like nice dashboards so that we can really clearly see where we have opportunities to deprecate things. And I wanted to say something about the emphasis of the benefits of migration. There might be times where the migration benefit isn't immediately obvious to the client. And so that increases the risk that we're going to have to maintain 2 versions of things and potentially how they interact for a lot longer. So we do need to do more to communicate why it's worth the effort of migrating. For example, is the new version more performant, or does it contain more useful information? So thinking about effectively incentives to get the client to migrate. Once all clients have migrated to the new version, we move on to the contract phase. And during this phase, we remove the old version from the interface and delete its artifacts, so things like code, configuration, and documentation. In a typical case where 2 versions are sufficiently decoupled, this phase is just a deletion, so it's really simple. So I wanted to instead just use this 5 minutes that I have to explore cases where things didn't go as we expect. So doing things like, answering a few questions, like how might we prevent accidental breaking change? We found that one of the ways of increasing our confidence that we haven't introduced an accidentally breaking change is via something called defense in depth. And I don't know if this is going to show an image. No, that's fine. Anyway, does everyone know what Swiss cheese looks like? The defense in depth illustration that I was going to show was just a few layers of Swiss cheese. I think the model was produced by the NHS many years ago and often used in postmortems. So when we think about trying to introduce, build effectively defensive software that give us a high level of reassurance that something is safe to use, we can use a few different layers of defense, which are effectively good practice, or rather just software engineering practices. So these are things like a layer of defense is called, one layer might be documentation, another might be unit tests, another might be property-based tests, another might be CI checks, and so on and so forth. So we layer up as much of these practices as possible, where each practice increases our confidence just a little bit more, and allows us to prove just a little bit better that the system is safe to use. And hopefully, no, that one's not going to show either. I'm just going to try reloading it because I think this one was quite nice. Or I could just show you. If anyone wants to look at some thought-provoking stories, we use a tool called Spectral, artificial. So one of these layers might be the use of tools in CI to catch particular issues. So Spectral, this is a tool that we can use in CI to automatically check and throw errors in CI if the generated Open API spec does not conform to a particular set of rules or standards that we can define ourselves. So I'm going to I just wanted to show one illustration of the kind of error message that you get using tools like Spectral. So this examines the output Open API spec which we generate and produces, takes some configuration. So you can say, I want to define my own rules around how I want this Open API spec to look, or you can use a lot of the common standard rule sets. For example, the OWASP 100 security rule set, or API casing issues and things like that. I cannot tell you the number of times I've accidentally introduced a casing issue in an API. So it's quite nice to have catching things like this in the CI, just to give us that extra level of reassurance before we merge the code. So this is just one of the examples of the layers that allow us to increase our confidence that we're not going to release something that breaks for folks. If clients don't want to migrate, I think this is probably a very real issue with folks either using versioning or something like this parallel change approach. If clients prefer to use a particular endpoint or operation or type, despite our best efforts to communicate the value, then it might prompt us to consider, to understand better the value that the clients or the API consumers are getting out of that, and actually whether we really do need to remove it. If it does incur an incredibly high maintenance burden cost, or if it's unsafe, or it's drastically, less performant than the alternative capabilities, or it's buggy or exposes information, or if it's a bug or an issue, then we would certainly do more to remove that field sooner rather than later. But in all other cases where we're just exposing different capabilities and additive improvements and features for users, it might prompt us to consider to understand exactly the value that they get out of it and whether we actually need to deprecate that capability in the first place. Finally, one of the points of feedback that I had when we first started talking about this was, if we using the addition of a field as an example, if we add a field, if we just keep adding fields rather than removing fields or changing them and introducing breaking changes, won't it start to become obvious to clients that when we've made mistakes or changes? So to use my casing messes as an example, there might be times where you introduce something like, oh, whoops, I really wish I hadn't pushed that. And it's a very minor change. It might be something stylistic or something. And so you might introduce a new field because you can see that clients are already using the existing one and you don't want to break their interfaces. It's possible that this convention, just progressively adding fields, might highlight where we've made mistakes, but there are several instances of really long running, well supported software out in the wild that has existed and been well supported and can still run in the order of years and decades and longer. So I would just encourage us to put that into perspective of yes, we might accidentally expose cases where we've made a where we've made a casing error, or small things where we've made a minor design error, and by exposing things in a purely accretive way, we can see it's obvious to the user. But I think that's a very, very small price to pay for an approach which gets us closer to designing software and published interfaces that have the longevity of years and decades rather than months. Okay, so I did just want to I think I'd mentioned this at the beginning. Actually, this parallel change approach isn't new, and it's probably been called a million other things. And maybe I just selected the term that made the most sense to me. But here are a bunch of references. These ideas and these suggestions about how we evolve APIs are not new and have been very well discussed in the past. It is entirely up to us as designers to pick what solution we'd like to do. So if you're not familiar with these ones already, definitely encourage you to have a look at explore some of the references to understand some of these ideas a lot more deeply from folks who have a lot more experience using them than I do. Thank you very much.